In this video, we'll discuss the flow of charged particles, which we call electrostatics. Now, I bet you've done this. Have you walked along the floor with your socks on? And as you walk, maybe you kind of slide your socks along a bit. Don't you sometimes get a shock? I'm sure you've experienced that. Here we have here a sock, not a very nice one, but a sock. Perhaps you're dragging it, moving it back and forth, and you get a snap, don't you? Kind of a spark. Well, what happened? What happened here is you had negative particles down here called electrons, and they move. They move from the floor onto your sock, and that's where you feel that snap. Charged particles, electrons, jump from the rug to your sock. Before going on, I want to say this. When charged particles move, they're almost always electrons. They're much smaller and lighter than say, protons and ions, so almost always we're talking about electrons moving, as we see here. Okay? Let's look more closely at the charges before and after. Now, this is a before picture. You know what neutral means? It's zero charge. So look at the sock. It's drawn here as neutral. For every negative, there's a positive, and they cancel. So the net charge of this sock is zero, and that's what we call neutral. Down here as well on the rug, for every negative, I've got a positive. So it's also neutral down here. Now it says here, when electrons move, the objects, that'll be the sock and the rug, are left charged. Their net charge is no longer zero. They're not neutral. Let's see how that happens. I said earlier this snap happens because negative electrons move. So let's say three of them move. So down here we're no longer in a situation where for every negative there's a positive. In fact, now because some of our negatives, the electrons have left, we've got more positives, don't we? Wouldn't you agree then that the net charge is larger than zero now? Sure, this rug is no longer neutral. It's positively charged. And then of course our sock, which was neutral before, received three negative electrons, didn't it? So now its charge is less than zero. It's negative, isn't it? So that's why I say here, when electrons move between two neutral objects, they are left charged. This one is going to be positive, and that one's going to be negative. Let's do one with a class example actually here. I forgot about one example. Is the balloon in a sweater. We start with a neutral sweater and a neutral balloon, and we do well before we go on. Here's your video code. Sweater. Then we touch the balloon on here. We rub it back and forth. And what's going to happen is negative electrons will leave the sweater and go to the balloon. Now they were both neutral before, but here's the ending result. This neutral sweater lost negative electrons, leaving him positive, whereas the balloon gained negative electrons, so he's negative. And that's your classic example of charges moving. It's called electrostatics, and the objects are left charged afterward. They were neutral before, both of them. Now one's positive, one's negative because of the flow of electrons. One more example. Here's an old CD case. So when you buy it, it's covered in a thin plastic, isn't it? You probably can't see it, but it's on there. And you got to take it off, don't you? There it is, a CD case in plastic. Now we take it off. We tear it with our finger or something. We tear it off. Then, haven't you experienced this? That darn plastic, this here, which is here and here, this sticks to everything, doesn't it? Sticks to your hand, sticks to your face. You shake your hand and it will come off. The darn thing it sticks to everything, doesn't it? Why? Why do you think that is? Well, here's the reason. Similar to the balloon in the sweater. When you do this, you tear this off, negative electrons jump from the plastic of the case itself to the plastic of the wrapper. This becomes very negative. There it is. It's negative. It'll stick to your hand. Negative stick to your face. It can be quite annoying. So that's it for this video. This is called electrostatics, where charged particles, usually electrons, are sometimes transferred, leaving behind charged objects, one positive, one negative. The neutral sweaters and balloon end up positive and negative. Here, the neutral plastics, both these plastics were neutral before. The action of tearing this off makes that one very negative, doesn't it? Because the electrons flow. And that's called electrostatics. Bye.